Odd-looking definite integral. Now this reads the integral from 3 to 4. The limits of integration are 3 and 4. You can see here the lower limit and the upper limit are 3 and 4. Now this says x times the floor of x times the fractional part of x. Now if none of that stuff was there, this would just be the integral of x cubed. You'd find an antiderivative and you'd be off to the races. But it's a little bit more involved than that, but it's not as bad as you might think. This piece right here, the floor of x, I'll just highlight right here. In this interval, numbers between 3 and 4 have a floor of 3. That's what the floor function does. For example, 3.2 would be in this interval somewhere. And so the floor of x is just 3. Right here, the floor of x is just equal to 3. Let me see if I can mark that in there for you guys. Let's see. All right, so right here in this interval, the floor of x is just equal to 3. Okay, so that'll be easy. You'll put 3 in there. It'll be a constant. It'll come outside, and you can see down here in the integration. That's what happens. So that part's straightforward. The floor function always returns a natural number or an integer. So it's pretty simple in that sense. Now the floor, the fractional part of x is slightly different. It returns the fractional part of x. But let me give you an example of how that would work. Let's say we picked, we wanted to do the fractional part of, let's say 3.6. Now you know just in your head that the fractional part of 3.6 has to be 0.6. Yeah, hopefully this is legible for you here. Okay, so that's equal to 0.6. I'll just, since I'm having such a hard time writing, folks, I'm just going to put 0.6 there, 0.6. But notice that's the same thing as just looking at this value right here, this x minus I. Okay, that would be the same thing as doing 3.6. Sometimes the Wi-Fi cuts out and then you lose the resolution on this marker, I think. But anyway, that's equal to 0.6. Okay, 0.6. All right, y'all, and you see, that looks like it's overkill. Like if somebody just gave you this problem, you'd say, well, the answer is 0.6. But you need a mathematical way to represent things. So you see what I did right here is I used this piece right here, 3.6 minus 3 is supposed to be this part right here, if you can read it, folks. Apologies for that. 3.6 minus 3 is 0.6. And you see that's exactly what we use right here. See, we use x minus 3. The 3, yeah, just from left to right, the x is the x, right? The floor of x in this interval is 3. And then the fractional part of x changes to x minus 3. So you see, you get a fairly straightforward integral. This part right here is just the fundamental theorem of calculus where you find an antiderivative. This part right here, or this guy right here, would be the antiderivative of this integrand. Okay, let me clear out all this mess. That didn't look very nice. All right, now let's move along to the next line. Now, y'all, again, this is the notation. They call it the evaluation theorem. This is the antiderivative, and you have to evaluate this expression at these endpoints and then subtract. Let me get to that next screen, and I'll show you. So there it is, folks. That particular definite integral evaluated to 11/2. All right, let me just flash back to the screen there, and I tried to keep it all on one screen, but it gets a little cramped up. But anyway, again, I'll flash over to the answer here. Hope this helps. Leave any comments if you have any questions or you want to see anything else similar to this work. Thanks.